Hello and welcome to my channel. My name is Fedor Sazanovets and I'm a senior .NET developer. This video is part of a series about solid principles and how to implement them in C# and .NET. Solid principles is something that every object-oriented programmer absolutely needs to know. And in these videos I will show you how to implement them in .NET and C#. For those of you who don't know what solid principles are, SOLID is an acronym. It stands for Single Responsibility Principle, Open-Closed Principle, Liskov Substitution Principle, Interface Segregation Principle, and Dependency Inversion Principle. In this video, we will go through Single Responsibility Principle. I will show you an example of its usage in a program that reads content of specified file, applies p HTML tags to each of its paragraphs, and saves the output in a separate HTML file. At the beginning, we start with just a single program class. Our entire logic is in this class. As soon as we launch our program, we are asking for the operator to specify the path to the input file. We then read the file content. We do it here. Afterwards, by using regex, we are splitting the content of the file into separate paragraphs. Our input paragraphs are just a collection of strings. After that, we are going through each individual paragraph and applying opening and closing tags to it. After that, we are placing break element at the end. And then we are saving the content of the file into a new HTML file with the same name as our original file. So, as you can see, there are quite a few things going on in a single class. In our case, we can get away with it, because our class is fairly small. However, in a real-life situation, this would be totally unacceptable. If we ever have to change part of the logic, we will have to change the entire class. This is why we need to separate our class into separate classes, each handling particular part of the logic. In our case, we can separate text processing logic from file processing logic. So we will start by creating a new class, and we'll call it File Processor. To make a start, we'll move Read All Text and Write to File into this new class. Because full file path is being used as a parameter in both of them, we can just make it a class variable. And this is how we get rid of redundant parameters and redundant using statements. Now we are going to create a separate class and we'll call it text processor. File processor will be a class variable of it. We'll add to it a method without a return type, and we'll call it convertText. This method will contain all the text processing logic. Full file path will become its parameter. And all responsibility for reading content of the file and saving new files will be passed on to file processor variable. So now we have a separate class for processing files and a separate class for processing text. So now we will bring it all together in our program class. So this is our finished product. Whenever we need to make any changes to our file processing capabilities, we only make them in file processor and nowhere else. And same applies to text processing logic. Text processor class is the only place where we need to make any changes. Therefore, our software is structured similar to a car engine. In a car engine, every single component is self-contained, However, all the components brought together form one working unit. In our case, it was very easy to determine what responsibility each class should have, because we were doing only two distinct things: processing text and processing files. However, in real-life scenario, it's not always as easy to determine single responsibility for each class. And this is where the concept of class cohesion plays its part. If certain class variables are only ever used in some methods but not the others, then the class is known to have low class cohesion. However, whenever a class variable is used in every method of the class, then the class is known to have the maximum class cohesion. In our case, our text processor class has a maximum class cohesion because it has only a single public method which uses the entire logic and all class variables. And the same applies to file processor. In this case, we have only a single class variable, full file path, which is used in both of our class methods. What we had before we refactored our code into separate classes was known as God object. God object is exactly opposite to single responsibility principle. Just like God, it is almighty. It does everything possible. It has many responsibilities. Having God objects in your code is a really bad approach, and at the beginning of this video, I have already stated some dangers of it. If you have to change just a small part of the logic, you will have to change the entire class. And this is how you may introduce the errors. When you are using single responsibility principle, each individual class has already been tested multiple times. So chances are, if you are at any point going to introduce the errors, you will only ever introduce the errors into the class that you are changing and nothing else in the system. But single responsibility principle doesn't only apply to classes, it applies to methods too. This is, for example, why in file processor we have a separate method for reading all the text from file, and a separate method for writing text into output file. And this is it for today. In our future videos, we will cover the rest of solid principles. So happy coding and keep your code clean. And if you want to see more educational content related to programming, don't forget to subscribe.